Alright, so this screencast is meant to explain to you guys exactly what I'm looking for to make a scatter plot on paper. And I'm going to show you how to do that. We're going to make sure we have all parts of the graph to be proficient, which includes a three-part title, x-axis label, y-axis label, appropriate scales and number lines, and properly represented data. We'll also look if we need a key or not. Okay, so let's get to the paper. So here we go. Got a little graph paper here. And the first thing I'm going to do is take a look at the data that's given to me. And the title is given. I'm going to put that on the top. So it needs to be a three-part title. We have females per unit area, which is in this title is the population density. And the average clutch size is the dependent, which in this title is represented as the number of offspring raised. And the little bit extra is what type of bird are we talking about and where? Song sparrows in Eagle County. So this is a pretty long title, but I'm going to write that all real quick on the top. So there we go. Three-part title. Next thing I'm going to do is get some labels on my X and Y axis. I'm numbers and numbers, and on your test I'm still debating, but I'm probably going to let you know whether you need to make a scatter plot here. So just so that there isn't a mistake. So with this, it's numbers and numbers. This is going to be my X, so the X-axis goes on the horizontal line. So Hicks, horizontal, independent, X-axis. Y is going to be on the vertical axis. So right here, again, I need to put numbers right on the edge. So I'm going to make sure I leave room for those numbers. And then below that, I'm going to write females per unit area. And then on the y-axis, I'm going to take the label that goes on the y-axis and write that down. Again, I have numbers, so I need to leave some room, and I'm going to just give myself a little bit more room here and write average clutch size. And there we are. So we are all set. We've got 3 out of the 5 big things we need. We've got our title and our X and Y axis labels. The next thing we need to do, I think, is probably the most challenging part, and that's to figure out exactly what our number scales should be, our scales on our axis. How are we going to spread out these numbers? So let's start with the X. I need to first make sure we're going below the lowest and above the highest, or at least to the highest, okay? So since these are fairly spread from really low, and they're incrementally changing here, it's not really a set increment, but they're going up. So what I'm going to do is I'm going to find my range. To find my range, I would take my highest minus my lowest, and that would give me 41. Now, I'm going to round that up and just go with 45. So I'm going to go from 0 to 45. And again, that's much easier. You guys can probably all do that mentally. But now, once I have my range, which is 45, I'm going to divide it by the number of boxes on this graph paper. So I've been using this same graph paper, but you might get a different piece of graph paper. So you still need to like count up all of these boxes. And I counted them up earlier, and I have 30 boxes here. So if I have 30 boxes, again, the range of numbers I'm doing, and I divide that by the number of boxes, and that would give me how much each box is going to be. So it's going to be 1.5. So I would start over here with 0. And again, it's important that I understand that the numbers go on the lines and not in the spaces. Now I've got 30 lines here. I'm not going to write a number on every single line. I'm going to skip some. But every single box is going to be 1.5. So if I skip to this one, I need to go 1.5 plus 1.5. So on my calculator, again, a lot of you guys can do this mentally, but I go 1.5, 1.5, 1 5/10 plus 1 5/10, and that would give me 3. Okay, so on this line, because it's 2 over, I'd write 3. Now, if I keep hitting the equal sign, it will keep adding 1.5 to it. So now I'm at 4.5. But that's one box passed, remember? So I got to hit it twice for the next box. So my next one is going to be 6. And most of you guys can count by threes, and you don't need to actually like keep using your calculator. This one's a little bit easier, but if I keep doing it, that would be the next box, but the next number I actually write down would be 9. Next box, next number, and I keep going until I get all the way to the end. And because everything actually worked out even at 1.5, I went the entire range across the entire bottom, and I just had exactly the right number of boxes. Okay, so this y-axis is a little bit trickier. If you look here, these aren't in order, but I still need to figure out the range. So I got to find my lowest and my highest, and I subtract those to get my range. Now, again, I would go below the lowest, or if this is even, I might just stay with it. And above the highest, I round that up to 4. So if I go like 4 minus 3, I would have a range of 1. And now, if we remember, to figure out how much each box is supposed to represent, I take the range, which would be 1, divided by the number of boxes. And if I count up all these boxes here, there are 22 boxes going up. So I'd go 1 divided by 22, and I'm going to get a really small number, right? So it's 0.04545. So I'm going to round that up to 0.05. So again, anytime if you have some scratch paper and you don't want to forget a number, just write it down. So every box is going to be 0.05. And am I going to start at 0 here? It's only going between 3 and 3.9. So if I started at 0, everything would be way, way, way up at the top of the graph. So I don't want to do that. So because I subtracted 3 and 4 here, I need to actually break my graph. So what I'm going to do is I'm going to take this, I'm going to make this little zigzag line. And then the first number I'm going to put down is actually going to be on this line right here. This is showing that I'm jumping a bunch of numbers between 0 and the first number I'm writing down, which is going to be 3.0. Okay, so remember, every box needs to be 0.05 because that's how I have it here. So I'm going to start at 3, and the next box up, I would add 0.05 to it, which would be 3.05. Now again, I don't want to write every number on every single one, so I just added 0.05 to this. If I hit equals again, it's going to add another 0.05, which takes us to 3.1. And that number I am going to write down. So this right here would be 3.05. This next line up, then once I add another 0.05 or 500ths, it would be 3.1 or 3 1/10. And I'm going to continue this going up now. So that would be the next box, but the next line that I'm going to write on is going to be 3.2, like so. And the numbers are small and they're really scary because they're kind of confusing when you're talking about hundredths and 0.05 and how much do I go up by. If in doubt, just use your calculator. So that would be the next box, but then what I'm going to write on is going to be 3.3. And now the pattern's easy, right? So I'm just going to keep going that way. All right, so I've got evenly spaced scales and number lines that range from the lowest data to the highest data. So now it's time to actually just put in my data. So I come back here, and the first point, this is just like math class now. I'm going to go over to 4, because that's my x. I'm going to go up to 3.9, because that is my y. So I go over to 4, and so this is 3, and this is 6, this is 4.5, so I'm slightly on this side of the line. So I go over to 4, I'm going to go up to 3.9, so I'm tracing this up, 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 up. Here's 3.9, and I put a dot. And that is my first data point. It's the exact same way I would make a line graph, except because it's a scatter plot, I'm not connecting the dots. So now I'm going to go over to 15 and up to 3.6. So over to 15 and up to 3.6, and I put another dot. Next one, I go over to 30 and up to 3.55. Over to 30 and up to, here's 3.5, here's 3.6, 3.55 would be right in between. So I follow that over and I put my dot. Next one, over to 36, up to 3. Over to 36, up to 3, and it was 3.0. So then I put my dot right there. My final dot on this one is 45 and up to 3.42. I go over to 45 and I go up to 3.42. So here's 3.4, here's 3.5, that line would be 3.45, and I'd go to 3.2 or 3.42. So that wouldn't be 3.45, it would be in between there. So I follow that over and I would go right to the edge because that's where 45 is, and I put my dot. Okay. So I have now plotted all 1, 2, 3, 4, 5. I go 1, 2, 3, 4, 5. I'm all good. Now again, it's a scatter plot. If it were a line graph, I would take a straight edge and I'd connect all these dots, but that's not what I'm doing here. I will allow you guys to estimate a line of best fit. A lot of times it's better on Google Sheets because it figures out exactly what it should be. But when I look at a line of best fit, the general trend I would say here is heading in this direction, right? And the line of best fit, you should have as many dots above and below the line. So if I am looking at this, here's one dot, here's two above, two below. Maybe this is a good idea to graph with a pencil. Make it nice and light. I'd say that's a pretty decent line of best fit. Okay. Again, if you use Google Sheets, it'll put it exactly where it's supposed to be. And Google Sheets can do a lot of amazing things here. You can find correlation coefficient. You can compare how closely connected the variables are based off of that statistical analysis. But for now, this is what we're after. Okay. One comment here, the further the dots are from the line in general, the less connected the variables are. The closer the dots are to the line, the easier it would be to predict some other missing data point here, which would make it the two variables more connected or more correlated. So let's make a quick wrap around this and make sure it is proficient. Thinking about the 5 characteristics, possibly 6 that I would need. And again, like all I'm doing, there aren't 2 sets of dots here, okay? So because we don't have like 2 sets of dots, I don't need a key to tell one set of dots from a different set of dots. So this is all I need right now. So let's make sure we have what we need. If I go here, I need a 3-part title. So do I have a 3-part title? Yes, I do. I have the independent, which is population density measured in females per unit area. I have the dependent, which is the number of offspring raised, which is average clutch size, and I have that little bit extra, which is song sparrows in Eagle County. If I go here, I have an x-axis label. I come back, I have an x-axis label. Do I have a y-axis label? So let's come back. I have a y-axis label. Heading back, do I have appropriate scales or number lines? I do. Here are my number line, my scales. And we did that math and figured out exactly how to space these apart. Then, do I have properly represented data? I plotted out my data points correctly. I have all of the data represented. And then I decided I do not need a key or a legend, so I now have a proficient graph. So I hope that was helpful, and keep watching these videos so you are ready for your assessment.